Good day everyone. This presentation discusses Algorithm B Adapted Coding Assistant, an AI-inspired system that provides context-aware coding suggestion. A practical demonstration in the application of the algorithm we recommended in our analysis report. Its main goal to help programmers by detecting coding difficulties and giving adapted recommendation based on user behavior such as typing, delays, and failed attempts.
So before we proceed, it is important to note that this is only a mini-project simulation of AI concepts. It is not a full artificial intelligence system, but a rule-based system that mimics adaptive behavior using predefined logic and scoring techniques. So let's start. So going to the structure of our code, at its core, the system works in 5 key parts. First is the suggestion pool, which stores predefined coding assistants like debugging tips, syntax checks, and performance warnings. Each suggestion has keywords and a relevance score. Second is the relevance scoring function. This is the intelligence layer of the system. It analyzes the user's input, detects keyword matches, checks typing pause duration, and monitors failed attempts. The more struggle detected, the higher the score. The third is the merge sort algorithm, which ranks all suggestions based on their computed relevance scores. This ensures the most useful suggestion appears at the top. Its efficiency is O and log n. So fourth is the adaptive logic layer, which includes cognitive load detection, which is based on pauses and failures, and dynamic pool expansion, which is adding new suggestions like recursion or input-related advice when needed. This makes the system flexible and responsive to new coding patterns. Fifth is the main program loop, where the user inputs code, the system evaluates behavior, ranks suggestions, and decides whether to provide assistance. If the user is highly struggling, it also activates a deep assistance mode with step-by-step debugging guidance. So finally, the system logs all interactions and displays a session summary, showing how many suggestions were given and overall system performance. In summary, this algorithm demonstrates a lightweight adaptive assistant using sorting, scoring, and behavioral analysis to simulate intelligent coding support.
I am now launching the Adaptive Coding Assistant. This system uses a merge sort-based ranking algorithm to provide help only when it detects cognitive struggle through typing pauses or repeated errors. First, let's look at the standard interaction where the user is in a flow state. Because the pause was short and the code was valid, the system status reports cognitive load within acceptable threshold. There was no suggestion shown respecting the user's focus. Now let's simulate a hesitation. I'll type in an if statement. Then put 6 as pause time. Even though the code is valid, the 6-second pause triggers a suggestion. Notice the relevance score of 15. It scored 10 for the if keyword and 5 points for the long pause, correctly identifying that I might be struggling with logic. The algorithm also adopts its knowledge base. Let's see what will happen when I use a complex concept like recursion. The system will detect the keyword factorial and dynamically adds a new recursion-specific suggestion to its internal pool. Finally, let's see what happens during a critical failure where the user is clearly stuck. On the third consecutive failure, deep assistance mode activates. It bypasses the standard suggestion and provides step-by-step debugging advice, such as break the problem into smaller parts and use print statement to trace variables. Now let's exit the program. And upon exiting, we are going to see the session summary. It logs our total interaction, how many times help was actually needed, and confirms the session complexity was big O and log N due to our merge sort ranking.